So hi guys, welcome to the second Conspiracy Extra. Today, I think this is to make up for a Mr. Conspiracy Extra. That was yesterday. On Monday there was a Mr. Conspiracy Extra. I want to make up for that. So here we are.
Stationary Earth. This proof comes from a mechanical engineer who goes by the name David. To the best of my knowledge, David is the sole discoverer of this mathematical proof, and I'm only here to share David's information with as many people as I can. Again, my email is tabooconspiracy@gmail.com.
I should check Taboo Conspiracy. I should debunk him. Yeah, I'll find you. I'll find your channel, and only then I'll debunk it.
If you'd like to share your expertise or inside information. Now, David is a flat earther, but what we'll be presenting today deals mostly with proving our Earth is stationary.
Wait a minute. David is a flirt? Oh, that means he's bad at maths.
Discovering our Earth does not rotate at 1,000 miles per hour is a necessary step for most truth seekers before they can accept flat Earth. It was for me. And
for most truth seekers, don't you mean like fantasy seekers? Like, this flat Earth is fake, it's fantasy. I mean, like, for some people, this sounds intimidating, like, a math equation, but I'm not intimidated. Show me the math equation already. You don't have to rant on about it. Okay, just go.
And the hired liars will fight against this information tooth and nail. But before we get to David's proof, I just want...
Hard liars? Oh, I'm not a liar, okay? You're the one lying. There is many proof that the Earth is round. And I think at this point, all flirts, they know the Earth is round, but they just dug a rabbit hole too deep. And now they have to continue on with this. They cannot admit it's wrong. They cannot be like, seek truth, speak truth.
I wanted to make a quick point. For me, proving a stationary Earth is quite simple. According to mainstream science, the Earth is spinning at the equator at the supersonic rate of 1,040 miles per hour. That's about as fast as this jet appears to be flying. But this is Felix Baumgartner. According to Wikipedia, it took him 2.5 hours to get up to 128,000 feet in...
It spins at 1,650 miles per hour, right? Yeah, but if we divide that by 20, but if we consider the size of the Earth in it, that size isn't blazing anymore. Like, try spinning a roundabout or a chair and make it spin in a full circle in one day. Blazing fast, isn't it?
A balloon. If the ground was spinning at 1,040 miles per hour, as claimed by mainstream science, then Felix Baumgartner should have landed over 2,000 miles away to the west over the Pacific Ocean.
Okay, not this thing again. Okay, so first of all, we have to consider a couple of things first, such as the air, which is keeping the balloon in the place. Okay, plus the balloon is so small that even when the Earth is moving, it's not gonna travel that much distance from the thing. There are physics at play here that make sure that the balloon doesn't travel 2,000 miles. Plus, the balloon is following the sky. You must remember the balloon is also following the sky, and the sky goes around the Earth. It spins with the Earth. So as the balloon is floating in the sky is spinning with the Earth. So there's the answer. It's with the sky.
Instead, Felix landed 43.8 miles east of his launch site. That's the wrong direction. Do you not see how fluid dynamics work and how none of these spinning movements and effects are evident anywhere, which would be most manifest at higher...
Hey, do you know why the water's spinning like that and falling down? I'll tell you why. Because of gravity!
For elevations like at 128,000 feet? I don't know why that one is so difficult for people to understand, but thankfully we have David today to give us a new mathematical proof that cannot be denied. The information presented will have huge implications.
Not this classic ball is the water go off. We have gravity pulling the water down. In fact, the water down is the reason why the water is flying off downwards from the ball. Because of gravity.
Because if what David is saying is true, and the math most certainly supports him,
but David is not saying that it's true,
then the Earth is absolutely stationary. There will be a lot of math covered, and I will certainly show you all the information I have at the end, but we're going to start with a simple summary. In this case, David agreed to make a quick audio introduction.
Hey guys, my name is David and I'm a mechanical engineer. Other than that, there isn't anything super special or noteworthy about me. I remember almost to the day that I became interested in flat Earth, immediately following the Las Vegas shooting in October 1st, 2017, I knew something was off. This led me down a number of rabbit trails, including 9/11, JFK, the moon landing, and then the biggest lie of all. It was so much easier back then to find information and videos on all these topics before the huge crackdown of censorship recently. It was probably about 6 months ago that I began really pondering specifically the proposed motion of a spherical Earth, and something just didn't sit well with me. It wasn't until I put pencil to paper that I realized something rather immense. And here it is in a nutshell. Having a background in engineering and modern physics, I began breaking down the forces that would act on all masses on a ball Earth. Of course, we have the force of gravity, which we're all familiar with, but trying to think critically like a good college-level word problem, was there something else, some other force or forces that I wasn't thinking of? And the answer is yes. Let's assume, and every ball Earther would agree with me, that every mass on planet Earth is being pulled exactly to the center of the Earth, which would be the center of all the masses around us in essence. Now imagine any point on the ball Earth and picture that point spinning around the axis of rotation of the Earth. No matter which point you pick, with the exception of exact north or south poles, all of those points have the same path. In other words, depending on your location, you may be closer or further from the axis of rotation, but every person and every mass is going around the axis with uniform circular motion.
Yes, oh yeah, that's true. We are going around the center of mass because we're spinning.
Again, any given point is spinning in a flat circle around the axis of rotation of the Earth. This means that there has to be a centripetal force that has a tendency to fling you in the opposite direction of the axis of rotation. Not opposite the center of the Earth, but opposite the center of your own flat circular path.
Oh, opposite force? Centrifugal force. There you go. That's an opposite force. That's gravity is fighting centrifugal force. There.
If we are to believe a ball Earth, then of course we know this force would be small and wouldn't overcome the force of gravity. So of course I'm not arguing we should be flying off into space, if that's what you want to call it. But as it turns out, this force is not negligible. This has huge ramifications because what it means is that everything on the spinning globe should be pulled, however small, to the equator. A tendency to flatten out due to the spin and gravity always pulling.
Gravity is pulling you to the center. The equator is not the center of the Earth.
You to the center. Mainstream science actually acknowledges this phenomenon because they themselves say that the Earth is oblate and bulges at the equator and has less of a circular diameter pole to pole because of this. And yet, I have never once heard that masses are pulled to the equator. So, to summarize, we are supposed to believe that uniform circular motion, or spin of the Earth, is powerful enough to smush the ball, yet we can't measure even the slightest force of pull toward the equator. Thank you guys for listening, and I just urge everyone out there to think critically and do your own research.
Now, let's read David's summary on the topic. The Earth does not spin. Uniform circular motion is the motion of an object traveling at a constant, uniform speed on a circular path. When an object experiences uniform circular motion, it experiences a force known as centrifugal.
Okay, so what did David say? He said that science, there is no and nobody's getting pulled to the equator. The equator is not the center of the earth. You know that, right? Yes, there is a bulge in the equator, but nobody's getting pulled to the equator because you're getting pulled towards the center of the earth.
Centripetal force. Textbooks denote this by showing an acceleration vector pointed directly at the center of the circular path. The mass itself experiences this force as the tendency to push it away, directly opposite to the acceleration vector pictured above. You can relate to this experience by thinking of when traveling in a car around a tight circular bend. Your body is being pushed away from the circular path by centripetal force. Consider the following diagram. Neil deGrasse Tyson is depicted here on two different circular paths. Facts. 1. If you believe in a ball Earth, then you have to concede that due to the spin of the Earth, the paths, highlighted in red, are the paths you would take if you were at either of those locations on the Earth over a 24-hour period.
Yes, yeah. Yeah, we go around in a circle. These paths, yeah, nothing wrong with that. I feel like you're gonna... What are you trying to prove here?
The arrows pointing at the center of the Earth in pink are the force vectors of gravity pulling Mr. Tyson to the ball Earth. 3. If you believe in a ball Earth, then you believe in points 1 and 2. Since you agree that the red highlight is your path in uniform circular motion, then, based on the laws of physics, you must concede that there exists a centripetal force, however small, pushing you away from the center of that uniform circular motion.
Yes, but gravity fights centrifugal force, so gravity wins. But yes, there is centrifugal force.
This is shown as a pink force vector in the diagram above, directly perpendicular to the axis of rotation of the Earth. Note, the center of uniform circular motion is different than the center of gravity of the ball Earth and changes dependent on your location on the ball Earth. If you are on the equator, the force vector of gravity and the vector of centripetal force are exactly opposite. Thus, the centripetal force, being much smaller, is effectively nullified. But what happens when you are not at the equator? Centripetal force and gravitational force are no longer opposite in direction, and that's key. Centripetal force and gravitational force are no longer opposite in direction. As depicted.
Okay, if yes, they're not in the same direction, but gravity is strong enough that the directions of the centrifugal force doesn't affect you much.
In the diagram, the angle of this difference is based on how far you are from the equator. Now consider the following diagram. Since the effect is mirrored on the southern hemisphere and across the axis of rotation, we can look at just one quadrant. The horizontal red centripetal forces get smaller the farther away from the equator you are because the radius of your circular motion is smaller. Black component forces show the centripetal force relative to the observer's up and horizon view. In other words, if we are spinning around a giant ball, we will have one component of centripetal force pointing directly upward from our perspective, which is effectively canceled out by the overpowering gravitational force in the opposite direction. We will also have a second component of the centripetal force always pushing us directly.
Basically what your point is, since centrifugal force is not opposite of gravity, we would be flying off to space. Even though the gravity is much stronger than centrifugal force. Okay.
Towards the equator. This is highlighted in the modified diagram below. Everything on the spinning ball planet, including Neil deGrasse Tyson, should be subject to the highlighted red force. The horizontal.
I want to mention that he turned off the comments. Like, he doesn't want to be debunked in the comment section. He didn't even turn on the dislikes and likes.